Keith. Great. Well, thank you very, very much, and take a breath. And it's quite an interesting insights on what can be done. Obviously, Australia, South Africa, and Chile have similar sort of results, and it makes a lot of sense to collaborate, especially that also we have all mineral industry. I'd like to bring in Ross. We're supposed to have two sessions, but I'm going to take him into one. Ross Hayward is a senior engineer at Hatch. He's also on the Center for Energy Technology Advisory Board. And he has been listening to the program since the morning. And I have asked him to do a bit of a reflection, and perhaps that will kick up some of the discussions we're going to have, and we'll try and take some questions as we go along. Ross, can you hear me?
I can hear you. Can you hear me all right, Bassam?
Yes, we can. Please go ahead.
All right. So did you want to start with a bit of an overview, or do you want to start with a question session for the panelists?
Well, we didn't get any slide of questions, but I'm happy to give it to the audience in here if they have any specific questions. But I thought what you're going to say is perhaps going to kickstart the discussion, and we'll take it from there. So maybe you could start, yeah?
All right. I'll try not to take up too much time in case there's questions that pop up. So first off, let me say a big shout out to the guys who are doing the audiovisual here at the last minute. I mean, I have to say it's been really well done. One of the people who was stuck at home as a result of all this coronavirus thing, I really appreciate the ability to participate and to listen to the presentations. And yeah, it's all been really pretty much seamless. I guess there's a few tiny hiccups this morning, but gee, it's you have to say the technology has been done really well, and well done to those guys who are pushing the buttons and turning the knobs in the background. I guess we had some really good talks this morning. It's wonderful to see such a diversity in terms of geography. We have people from all around the world with all sorts of different backgrounds, be they academic, industrial, or industrial research organizations. And we've covered quite a few different commodities, from phosphate through copper, lithium, manganese, et cetera, et cetera. So, and I might add, all of these are effectively new to the HiTeMP. I think when I look back over what happened 2 years ago, none of those were mentioned at the time. So it's wonderful to see the diversity and the, shall I say, inclusiveness of all this now. I guess a couple of things that occur to me in terms of what we've heard, and I'll first start by just talking about some of the commonalities. And I'd also like to stand up in my soapbox and just talk a little bit about the HBI project, because I have some direct experience in that one. I was actually involved way back when with some of the piloting that was done and whatnot, and I think it might be worth just maybe mentioning a few things on that, because it seems to crop up here today, and also I noticed it crept up in the iron and steel sessions yesterday. First off, and let me start with a bit of a qualification here. I just want to caution the academic community, and I don't want to be seen to be sledging here, but in terms of the industries we're dealing with here, it seems to me the academic community tends to be a little bit dismissive about some of the issues and some of the barriers to doing things. I hear people make comments about, oh, we could just, make a reduced iron and sell it, or adopt this new technology here and there. But I think it's really, really important to keep in mind the capital structures that are already in place in the world, the risk adversity that goes with the fact that you're operating and maintaining and trying to sustain a multi-billion-dollar facility, such as you saw the pictures of during during Matthew's presentation this morning, and all the risks that go along with that. There's also this mindset of production. So there was some mention about virtual batteries, and I think these are great ideas, but let's not underestimate the resistance to new thinking such as this. So again, keeping in mind that I come from an academic background, and I'm not trying to throw any darts here. I just want to make sure that we all keep clear what the barriers are to some of this new thinking, and what it will take to get them over the line, if you will. One of the common themes that seems to come through here, and I've already kind of mentioned, is a change in thinking. And we've seen the aluminum industry adopt this green product thing, and this foments thinking amongst the consumer about what exactly they're buying and what the product is, its green credentials. It seems to me that opportunity might also exist for copper. And I think that's an interesting way of thinking. This virtual battery one also kind of intrigued me yesterday, and I asked the question today. It didn't come through very well in Slido. In fact, I think Matthew thought I was trying to throw him a curveball. But in fact, all I'm asking is, is that same idea of ramping production to meet green energy availability one that can be extrapolated from? It's been mooted yesterday for aluminium smelting. Could that also be transferred to the copper industry? And you think about some of the things that happen in copper that take that are the big power draws, the SAG milling, for example, at Olympic Dam. Could that be? You're just going from a SAG mill to a stockpile anyway. Is there any reason why that couldn't be done in a more opportunistic way around the availability of power? So I think that's kind of interesting change in thinking that would maybe benefit all of us. I think the thing that probably goes against it is our current thinking. A production superintendent, he wants to get a certain number of tons out the door week on week, day on day, and so there's going to be some change in the way he's rewarded for his job. So some challenges there. Another common theme that I see here coming through is, and it kind of goes along the lines of the sale of real estate. It's location, location, location. And we hear about Australia, we've heard about Chile, and we've heard about South Africa, all with fantastic resources. And this idea of co-locating plants with the resource seems like a really good idea. Also requiring a bit of a change of thinking. Typically in the past we put plants where conventional power was available, where transport access was available. So maybe this requires a bit of a change in thinking, but clearly this idea of co-locating facilities with solar resources is a really good one. Good engineering and technical development process, and this kind of leads me into the HBI arena. So I think there's still clearly, this is something that has to go on, and we see the failure of the HBI plant, and in many ways that was caused, to my way of thinking, by failure to do a proper job of stage gating the development process. So I think that the need for good engineering and technical development in terms of scale up and the like is really critical to getting these new technologies over the line. I rather enjoyed Keith's comment about cringing when he talks about using electrical energy to provide heat. I feel exactly the same. I think, and again, as engineers and scientists around the table here, we have to be kind of looking at solar thermal first. I know Gus always thinks that way, and I applaud him for that. And using electricity to as a source of heat is kind of a second choice alternative. And I guess just going backwards a little bit here in terms of a change of thinking. And I was interested to hear from Assam about the Scope 3 emissions and how that's all going to play out. And I have to say I struggle with that one a little bit, because it strikes me that Scope 1 and 2 is what I do in my backyard, but once I throw something over the fence, well, what the next guy does with it is kind of his business. And how can I be responsible for that? And it's very difficult to enforce some responsibility for that on me without some kind of broad intervention by government or governments around the world. I think until there's some kind of a global response that really says, ultimately, you know, here's the CO2 cost of this item, until someone has to finally pay the price for that globally, I find it really difficult to see how a Scope 3 emissions target, or trying to reduce Scope 3 emissions in isolation, is going to be very effective. So I'd be interested to know a little bit more about how other people's thoughts on that one. And I guess that's about all that. I've kind of rambled a little bit here at the end. I apologize. Yeah, I think I'll stop there. I'll probably take up enough time anyway, and I'll turn it back to you, Bassam.
Oh, thank you, Ross. It's really valuable. I'm going to come a little bit to defend academics. You started your remarks talking about how well technology is working. And of those who have been developing the technology for online meeting didn't think a coronavirus would happen, and then we'll need it almost overnight. So academics should be free to think, you know, and dream. And then when and if it becomes financially viable, the industry would then be able to use it. So obviously, this forum is one indication that we're not going to ignore the dollar sign and the requirements and the legal and the investments required by virtue of having industry representatives and people like yourself on the norm. So I think we should never limit academics' ability to innovate, I guess. But we're lucky to have people like yourself and others to bring us down to earth every time we sort of want to fly. But that's just a contribution on the side. I'd like to invite questions from the audience, and if there's anything online. Okay. Maybe you could ask the question first, and then John is second, please.
So there is one question from Kate, from David Cochrane. He's asking, as per the availability of cheap and cheerful PV panels, do you think is there much scope for a significant reduction in capital costs of solar thermal from countries such as China?
Okay, and what's the other one? Is it related?
So, no, it's not. It's not.
Okay,
related.
let's then wait. Keith, you want to comment on that? So the question is about China. Obviously, it's a bigger emitter, and would solar thermal make any difference there?
Okay, I sort of took the question as, is China going to drive a cost reduction in solar thermal?
Okay.
Yeah. And I think probably the answer is inevitably yes. For those of us who are engaged with how solar thermal is going, or concentrating solar thermal in particular, you probably realise that the global deployments had a little bit of a pause for a couple of years, but they're actually growing quite strongly now, mostly due to Chinese efforts, the Chinese plants being installed, but also the Chinese companies are increasingly represented in international projects, like the big one in Dubai that's coming up has nearly 50% Chinese content, I think. So, I mean, in terms of cost reductions, my feeling of every technology, and this goes to almost everything we've discussed, is without exception, the sort of economic empirical rule of a learning curve, you get somewhere between 10 to 20% cost reduction for every doubling of deployment. I think that applies to everything. So people who like to say, oh, this will reduce, but that won't, I think they're wrong. It's, you know, everything will reduce. But we have seen it is China who seems to have taken the lead in lots of technologies, and, you know, full credit to them, but maybe the rest of us should try a bit harder too.
But that's also part of the economy of scale, is that they can't afford to build big plants and do the learning through it, because obviously they have much bigger demand. I mean,
yeah, no, that's a fair point too, yeah.
Another question, and then John here.
There is a question for Lina. They would like you to comment on the fundamental advantage of particle for high temperature heat storage versus the use of fluids such as sodium or silicon.
Okay, fluids like sodium or silicon, they mean silicon-based heating oils, I assume. So, yeah, I think I'd like to refer that more to Matti, but I'll do my best to answer it. So one of the advantages of particles is there's no risk it's going to explode. They're very stable. They also have like a higher decomposition limit. So you could see that the bauxite particles could be heated to 1,000 degrees Celsius easily without having to worry about decomposition, things that you have to worry about with oils and also with salts. So sodium, of course, is a very good heat transfer heat capacity and is a good conductor, which is the main advantages. At the moment, I think my feeling is we're waiting to see if it scales up. And it's mostly, you know, the concerns about safety is always there. So I believe it will be done, but also we have to consider, if I consider a new plant in South Africa, I'd feel more comfortable running it with bauxite particles than with sodium. If we have to train our local people to run it. So those are some of the concerns and advantages regarding particles and sodium and other heat transfer fluids commonly used. Thank you.
I think it's worth throwing in too that one of the advantages of particles is it's both capturing the heat and storing it, whereas sodium is really just a heat transfer fluid. It's also quite an expensive material, so whereas the bauxite's quite cheap. So.
John had a question here. John? Yes.
Keith, that was a beautiful presentation, a great breakdown. I was just going to ask or comment, the breakdown you had on the iron and steel sector, you had coal exclusively, and then when you were looking at the natural gas, which we went through very quickly, I'm not sure if you apportion that to the iron and steel sector as well, because the bubbles overlap, because they're also involved in the steelmaking process. I'm not sure if you're going to make them additive, so you've actually got natural gas contribution in terms of their input to the steelmaking processes, and then you had the coal separate. So I was just wondering...
Not sure if I followed all that, John.
Okay.
So basically...
So you started off with your breakdown, and you had energy input
to
to
the
iron
pie
and
chart.
steel right at the beginning. So you had most of that comes from coal, coke. Then towards the end of your presentation, you've got natural gas, and some of those bubbles also in the same regions because lots of that natural gas is used in the same process, so it's really additive. So you've actually got a natural gas contribution towards the iron and steel sector and a coal, coke contribution and some electricity as well. So talk about that.
Okay, let's...
So basically saying, initially you were talking about coal and coke for the iron steel making, and later on sort of included also natural gas, and is this just for the steel making component, or you had two sources of energy in there?
So the bubble plots by industry sector, they are total heat use from all sources on the map, right? But the pie chart of energy use, we attempted to, for the sector where I was talking about iron and steel, we tried to show all of the sources, energy sources for process heat. So
Okay.
I think...
Gus?
Yeah.
Yes, I want to return to the earlier question with a comment and a question for Lena on the heating. So another advantage of the particles compared to sodium and also salts is they can go to a higher temperature, which impacts the solar share or the solar fraction into that process. Lena, in your presentation, you didn't actually mention what the solar share is. You said you're estimating a 50% energy cost reduction, but if you're heating, let's say, 350 to 800, that's like 450 degrees, but you need a 1200 process, and you've got the heat losses, and you've got an enthalpy component, and you've got a solar fraction of the capacity factor, if you like. Back of the envelope would suggest that the solar input into that process is going to be no more than 30%, but can you comment on what you estimated it would actually be in that process? You just talked about the dollar saving so far.
Yeah, so maybe just a bit of a clarification. So this is for Matty's sinter plant application. Okay, so what we looked at was heating air to 800 degrees Celsius. So we weren't trying to sinter the manganese ores. We're trying to just reduce diesel consumption in that ignition hood. So
Understand. But the point is you're only heating the air from 350 to something like 800.
Yes.
But the process temperature is around 1200.
The process, the temperature in the ignition hood, they control it at about a gas temperature of 1,000 degrees Celsius, maybe 1,100. So remember, this is just to ignite the coal. So the 1,200 is to obtain sinter, and that's done with the carbon combustion. So in the ignition hood, the temperature is 1,000. I think originally Lars was also involved in the project. He estimated the solar share at about 60% when you are contributing solar. If the capacity factor, of course, is different, and that was calculated at about 65 to 70%, if I remember the numbers correctly. Am I sort of answering it?
No, I want to know the solar share into the whole sintering process.
It's still very low. I'm looking at can we replace some of the coke with preheating, similar to what we're looking at the Prima project. That paper will probably, I hope to get it finished in a month or two. Watch the space, we'll publish it then. The idea is, as I said, to use savings of diesel to cover the additional cost of solar preheating to reduce the carbon, and then we'll have a higher solar share, and we'll also have lower CO2 emissions. So if you look at the whole process, replacing the diesel makes monetary sense, but not so much mitigation of carbon emission sense. So yeah, it's under development.
Other questions? Okay,
Sam, could I? Am I allowed to interrupt and ask another question? Just one for Keith, and it goes back to the cringe factor question. Keith, you talked about heat pumps, and I'm kind of curious about that. You mentioned limitation being the temperature lift. I would have guessed there's also limitation about the maximum temperature you can get to. I'm just wondering if you have any comments about that, and also generally speaking about who's working in this field, and what are the sort of key avenues for research and development to try and improve heat pumps in this kind of application.
In terms of heat pumps in what you might call a conventional sense, I think our understanding is the maximum achievable temperature is about 150 degrees now. But as you might know, Ross, also from our alumina project, that we did find that mechanical vapour recompression, meaning recompression of low temperature steam, that works quite well and can go to pretty high temperatures. That is actually a kind of heat pump, if you will, with steam as a working fluid. In terms of R&D, I must admit I don't know. Maybe other people can comment on where that's active and who the players are.
there is a new center at DLR, Gus it's called. I can't remember what it's called. The guy called Uwe Riedel, who's actually just being started. And their main drive is to improve the temperature for heat pumps. Gus, you want to comment on this?
So this presentation was scheduled to be given in this forum, but was unable to be given due to the travel restrictions. But we're anticipating and hoping that will still be presented and made available online sometime soon after the forum itself finishes, so we'll get that input then.
Yeah, so Ross, you're still in the money. There is actually an attempt to increase the temperature from heat pumps for the exact purposes that you're thinking about. I'd like to quickly go through these. Sorry, Ross?
Sorry about that. One final question.
Yes, please.
Just for Lena, and again, coming back to the practicalities of things, I really had an interest in discussion about dust. Here's one of these really practical issues that probably gets swept under the carpet along with other dust, I suppose. I'm just curious, where did that lead you then? Is dusting likely to be a big problem, or how are you guys going to get around this?
Okay, so we have the weather station on site, and everybody can now go and look at the weather station online. It's free from the South African University Radionometry Network. So that's freely available now to everybody. The measurements of the mirror reflectivity and dust soiling, that has started this month. So we are just starting to collect the data. And we hope that we are definitely releasing the dust management strategy that we're developing for the project. Will be done in month 36 of the Prima project. So it started October 2018. So it's about a year and a half. Then we will have that results. But we will keep on publishing things that we find. This is also part of an MSc study. If I'm going to see if I can send my student to Solar Paces this year. At the end of the year, there might be some preliminary results then available. But yeah, we do want to address the barriers. This is why we are talking at these forums and why we motivate these side projects, because we're still a new technology, so we have to gather data. We have to work at the issues surrounding our technologies. So yeah, watch the space.
So my understanding for solar thermal applications, operation and maintenance, O&M, is a relatively small cost as compared to the total cost of the plant. So even if you double it or triple it, it's still a small amount. Is that true?
Sorry, could you repeat that?
So I'm saying in the total cost of a solar thermal plant, operation and maintenance is 2 to 3% of the lifetime?
Yeah, so operation and maintenance is a small part of the cost of the technology, but you know, it is there's the perceived barrier and the actual barrier, if I can say it. So it's perceived as a barrier, so we have to address it with scientific data. That's why we are investing in the study. So we'd like to say this is not actually a barrier, but we need data to back that up. So also it aligns also with water use in solar thermal. We want to know if this is going to be worse or better than current power plant solar thermal applications. So there's a lot of interesting questions that comes up once you start to think like, how will this actually work on the actual site?
Okay.
If I could just offer, I think it's a bit more significant than that. I think in terms of an LCOE, it could be 10, 15%.
Of the total cost.
And if you say a lot of that is about cleaning, if you suddenly got a site where you had to double it or you unexpectedly doubled it, it could make quite a big difference. So it's not something you'd want to be taken by surprise on.
You need to quantify the cost.
Which is the whole point of having mirror soiling things.
Ross, do you have any more questions on this topic?
No, that's good. Thank you very much. And once again, I really appreciate Keith's pragmatism in all this. It's a wonderful, refreshing.
Okay. So I want to go back to the questions. If you could flip the slides, please. And I want to do this quickly if we can. And then the first question is, what change happens in the last 18 months? And perhaps I could start with Ross, who sort of reviewed other presentations, and then I'll come to the panel here. What's to your mind happened sort of in terms of CO2 mitigation over the last 18 years, Ross?
I'm sorry, do you want to repeat that question?
I'm sorry, I'm saying what changes in terms of CO2 mitigations happened over the last 18 months? Gus is looking at me and saying, not 18 years, 18 months. So since the last forum we had, has there been breakthroughs in terms of energy or investment in CO2 mitigation in the high temperature industry?
Listen, honestly, I haven't seen, I'm not aware of any real breakthroughs if you're talking about step changes or, major technological implementation of major technical changes or new equipment. It seems to me that the whole process is a very slow, steady, grinding one, and it's just going to have to continue that way.
That's fair enough. Keith?
I might be just restating the obvious, but it seems to me that the biggest, it's not a technical change per se, but in terms of an influence, is the interest in hydrogen, which is really just, in Australia, it's really sprung up in the last 2 years. And I think it's a sort of global thing as well, but it's now almost central to everything we're talking about. It's a big shift.
So hydrogen is framing as something that's not going to fizz away and it's likely to be part of the future with CO2 mitigation?
I think it is, yeah, sure.
Okay. Lena, you want to add anything?
Yeah, and Keith, I agree with you, and that's true amongst the academic and the political community, it would seem, but really honestly, from an industrial standpoint, the uptake is at this stage is minuscule. I mean, we've got, at least with Hatch, I can speak of, one plant in the remote part of Canada where generation of hydrogen is something that's done. Everybody else is pretty much sitting, waiting, and seeing what's going to happen, I think.
Okay.
Yeah, no, that's fair.
You want to add anything?
Okay, so maybe if I can be a bit selfish and look more to South Africa, I think for us what was encouraging is that we could manage to get international funding for projects like the Prima project. It's an EU-funded project. But we're doing a lot of relevant work for South Africa. And as a developing country, that's very nice for us to see that we can tap into international research funds. Thank you for the international opportunities that there are. And also that we have managed to get quite a few South African state grants for our research. So for us, it's very new. Stellenbosch University has been working in this space much longer than Mintech, where I'm employed. So we do see interest in research, and we don't have industry acceptance yet. There's no commercial plant at the moment, but we are starting to talk to people, and I always believe that's the beginning of progress. We are starting to get requests that they ask us, okay, usually they want to know solar photovoltaic panels, and then we say, yeah, that's very great and well, and if you can, you should. Have you considered other options? So there is definitely from industry some appetite for renewable energy. There is still unrealistic expectations. Sometimes when they hear, no, renewable energy probably can't supply you with a constant base load, you can see the shock and the horror. For me as a researcher, I've sort of become acclimatized to the idea. I know the ways you can have backup technologies and all of that, but I believe industry still needs to get accustomed to that before they'll accept the risk of investing in it. And we can only talk and do studies and motivate that these things are possible.
Okay, the next thing we're going to try and answer is, and perhaps I'll start with Ross, I'd like to put together enablers and barriers. Do you think these have changed, Ross, sort of lately, and is there any new barriers or new enablers that we need to consider in mitigating CO2 in this sector?
Well, from my perspective, I think many of the enablers and barriers are really the same as they were 18 months ago or 2 years ago, whatever it was when we had the last forum. And I think it strikes me that the single biggest barrier is that we don't have a level playing field. it's great to say that we should use solar energy to produce a product that would be saleable, an iron ore product, for example, that would be saleable to China to allow them to make a lower carbon, effectively a lower carbon steel. But if they don't get any credit for that and they're paying a premium price for the product that they're buying from us, well, there's obviously no incentive for them to do that. And I think until there's a more globally level playing field that rewards that kind of activity, it's going to be very difficult. I think that's one of the most significant barriers that I see.
Let me just follow up this, and I'll give the panel here an opportunity. Minister Taylor, Angus Taylor, wants to invest in technology for low carbon or decarbonizing the industry or heavy industry. And if this is the plan or the policy or the strategy, the expectation is that there will be some funding that will follow. Do you think this will make any difference in the next couple of years?
Well, I guess it depends what context you place that in. Are you talking about an Australian context, or are you talking about a global context? Because the fact is, the steel that we make is by and large domestically consumed in Australia. So I would assume that government measures here would lead to a greening of the steel industry, or, and God forbid, push it to extinction. And all steel will now come from China because they don't have to necessarily abide by those same regulations. So within an Australian context, I suppose, yes, it has the possibility of getting us to the right outcome. Globally, again, I don't see it, because if I'm a Chinese steel mill and I'm producing a ton of steel, I'm going to buy the cheapest iron ore I can find. I don't see any reason why I would want to pay extra for a green product unless I can then at the other end of the business cycle charge more for that product, or have people want my product for the intrinsic value of the fact that it's green. Okay.
Panel here, Keith.
I'll have a go at barriers. Look, I briefly mentioned it on my conclusion slide, and Ross has actually articulated it more strongly, which is that within industry, there's very strong technically risk-averse thinking, and quite rightly so, because the stakes are very high, and you can't, if you derail production, that's just about the end of the company often. So it's rightly risk-averse. They also have very high expectations on return on capital, and the thinking there is, well, often capital is a finite thing, so you look for the best investment. And so if you could increase production, that'll usually give you a better return than saving a bit of energy. So that's a problem too. But on the other hand, what is potentially an enabler, and I think this has evolved a bit in the last few years, it's to see bigger companies like BHP, One Steel and so on, actually committing from a top level, from a board level, to net zero by 2050, this sort of thing. So if you get this top down, we must meet a target, I think that creates a lot more action and sort of stirs it up, because the people who, well, if you make it the KPI for the middle management, and somewhere in this forum, someone talked about the concept of the clay layer of management, which I loved. I hadn't heard that before. But, you kind of have to make achieving the target the strong KPI for the manager rather than the maintaining production. And so I think there's an enabler happening there, which is worth noting.
Absolutely, yeah. And that happened lately, of course, yeah. Lena?
Okay, so in the South African context, at the moment, there's huge interest in renewable electricity options from industry, but there are policy barriers. So that needs to be addressed. At the moment, if you want electricity for your mine or your minerals processing plant, you have to own that. You cannot get somebody else to do it for you and just buy it. So there's talk around that this might change in future, but at least now we're talking about changing it, which a couple of years ago was not even an option. Then enablers, I think a message from the top is a very good enabler. In South Africa, at the moment, you know, in South Africa, our priority is not CO2 mitigation, and I feel like a Philistine saying it at this forum. But our greatest motivation is job creation and industry development. We're a developing country. So if we can get funds to create jobs and green industry and mitigate at the same time, that is the ideal solution for us. So from South Africa's side, we say, please keep considering developing countries. We like it that we can partner and help drive down global emissions, but still develop in a green and sustainable fashion. Thank you.
Well put, yeah. Okay, so I'm conscious that we're running quite late. The other two aspects we have is the readiness of the technology to do low net carbon, and also the pathways or anticipated pathways for CO2 mitigation. Now, besides sort of the hydrogen, do we feel that there's any new breakthroughs that we need to consider that have changed from last time? Ross?
Yeah, I guess, again, the situation hasn't changed greatly from 18 months ago. I think I like this idea of this virtual battery idea for operating plants as green energy permits, if you like, whether it be smelters, aluminium smelters or copper smelters. I think there's certainly some merit in that. Readiness, I'm not sure. I think the big barrier to readiness there really is not so much the technology as the mindset, if you will, of the people involved. I think that there's been talk about oxygen generation and more solar input into oxygen generation. I think that still is an area that I think could benefit from some good creative thinking from academics, and I think that certainly has a lot of potential.
Thank you.
Actually, I'd like to go back to, we sort of passed over a comment you made earlier, Bassam, about, well, if there's going to be some money in this area, is it going to support pilot plants and so on? I mean, for our study, we did actually do quite a few stakeholder interviews and tried to explore these sort of issues. And it was apparent that for these very people who are technically risk averse, that what they want to see is, you know, they don't want to be the first one to put their head out of the foxhole. They want to be able to go and visit a working example of exactly the thing that they would implement. And if they can see that it's working for someone else first, then they'll think about it. So I think in this case, you know, serious money for serious pilots can make a difference. And with the commercial readiness, so if you go to that table I had where we had the short-term opportunity, and of course it's smaller than the long-term opportunity, but it does mean it's our attempt to estimate things which are commercially available, could even be done with a positive IRR today. So in that case, they're ready. Now, an example, I think, that has developed in this sector in the last 2 years is the take-up of PV battery type systems for power. So we actually have seen that sort of get over a threshold. It's been demonstrated with pilots. People start to get an acceptance. They've done it, so I'll do it. So yeah, you know. So that kind of proves you can introduce things. But of course, the really techie particle receivers and all the rest of it, great stuff, that's got a while before it's into the same kind of commercial readiness stage.
Good. Lena, you have something to add?
Yeah, so definitely one of my repeating refrains is We need to pilot, we need to demonstrate. The hurdle there is also getting industry participation, even if it's just, say, demonstrating it for my process. So even though we have all these case studies, industry is still not likely to put a toe in unless it's totally de-risked for them. And even then, they might have other priorities and just it won't go. I am doing a lot of talking and motivating. In South Africa, we have the Green Climate Fund. There's a huge amount of funding allocated to developing countries, but you might be shocked to know that South Africa only has 5 projects registered on the Green Climate Fund at the moment. One of them is for changing adapting financing for CO2 mitigation and climate change. The other one is for biodiversity conservation by shepherding, you know, and only 2 other ones vaguely related to industry. So I think there's a lack of awareness of the type of funding we have to do demonstration projects. I'm trying to also invite industry to come to people like Mintech, like DLR, like people who are doing the case studies and say, like, would it work for me? You know, there's lots of ways that we can have top-up funding and partial funding if we put our minds together and get teams together to solve the problem.
Great. Well, with this call to the industry to put their money where their mouth is, I think is maybe a good place to stop. Thank our panelists again and the speakers.